Hello there, it's Cikgu Zana here and you are watching Cikgu Zana's channel. Assalamualaikum and salam sejahtera. In today's video, we will learn about the number of solutions a linear system can have. For a better understanding of today's lesson, it is advisable to watch my previous video on solving a system of linear equations using Gaussian elimination. Okay, shall we begin? As we have seen in the previous video, we have used the row echelon form method to solve a system of linear equations. Similarly, the number of solutions for the linear system can also be determined using the row echelon form method. Consider an augmented matrix of a system of linear equations that has been transformed into row echelon form. Then the system has no solution if the last row of the row echelon form contains an equation 0 equals C, where C is non-zero, or a system can have one solution if each variable in the row echelon form is a leading variable, or infinitely many solutions if the variables in the row echelon form are not all leading variable and the system is not inconsistent. The matrices below, all in echelon form, illustrate the three cases. A linear system with no solution, a linear system with one solution, and infinitely many solutions. Let's look at the example for a system with no solution. Firstly, we need to write the system into an augmented matrix. Then, by Gaussian elimination, we will reduce it into echelon form. To do so, we must have zeros below the leading entry. Thus, subtracting 2 row 1 from row 2 to produce a new row 2. Then 3 row 1 is subtracted from row 3 to produce a new row 3. And we have zeros below the leading entry 1. Next, subtract row 3 from row 2 to have a new row 3. And we can stop, since the last row is all zeros except for the final entry, which is non-zero. Note that it doesn't matter what the number is as long as it is not zero. Hence, since the third row corresponds to the equation 0 equals 2, which is false, and no matter what value we assign for the variables x, y, and z, the third equation will never be true. Thus, the system has no solution. A system with no solution is said to be inconsistent. Now, let's have a look at a system with infinitely many solutions. As usual, the first step is to write the augmented matrix for the system. Then we will reduce it into echelon form using Gaussian elimination. So to obtain zeros below the leading entry 1, subtract 2 row 1 from row 2 to produce a new row 2. Then subtract 2 row 1 from row 3 to produce a new row 3. So we have zeros below the leading entry 1. Next, Row 2 is subtracted from row 3 to produce a new row 3 to have a 0 below the leading entry 3. Then multiply row 2 by 1 over 3. We have an augmented matrix in row echelon form. But notice that the third row corresponds to the equation 0 equals 0. This equation is always true, no matter what values are used for x, y, and z. Since the equation adds no new information about the variables, then we can drop it from the system. Hence, the corresponding system of equation is, since both of these equations contain the non-leading variables z, so we rewrite x and y in terms of z. We have x equal y minus 5z minus 2 and y equals 2z plus 2. Back substitute y equals 2z plus 2 into the first equation, and we have x equals negative 3z. So we now have x equals negative 3z and y equals 2z plus 2. To complete this solution, we let z equal t, where t represents any real number. Expressing x and y in terms of t, we have x equal negative 3t and y equals 2t plus 2. Thus, the solution written in order triple is negative 3t, 2t plus 2, and t, where t represents any real number. Note that we can allow a specific value for t. For example, letting t equals 1, thus we have x equals negative 3, y equals 4, and z equals 1. But since there are infinitely many choices for the values of t, thus there are infinitely many solutions to the system. Hence, the system here has infinitely many solutions. Now, for a system with one solution, you can refer to my previous lesson video on solving a linear system using Gaussian elimination. Please click the link given in the description below. Let's summarize what we have learned today. Given an augmented matrix in row echelon form, we can identify the number of solutions of a linear system. That is, when the last row is of the form 0 equals c, where c is non-zero, then system has no solutions. Next, if each row has a leading entry 1, then the system has one solution. And lastly, if the last row is of the form 0 equals 0 and the system is not inconsistent, then system has infinitely many solutions. That's about all for today. Hope all of you have understood the lesson. Till then, don't forget to subscribe, like, comment, share, and watch out for the next video at Cikgu Zana's channel. Bye!